Hello, this is Ronald Cardona, and I will be explaining example number 4 from the book. This is from section 1.3, so let's get to it. So in here, they're saying figure A identifies the selected linear combination of B1, which is a vector, and then we see it represented as -1 and 1. So if you want to visually see this, let's say that this will serve as X, this will serve as Y. Um, and so we go to the graph or to figure 8, whatever, and we see that did they went from the origin point 0 to -1, because this is a negative side, of course, and then 1 over here. So yes, this is the vector that they got from the given example, whatever. And now all of these vectors, they can be scaled by 2. For example, B1 is the original given combination. And then we have 2b1, which is scale uh, 2 times the original size. And then we have 3b1. Oop, sorry. We also see that we have a vector b2. And just like b1, we see that they start at the origin and goes 2 steps and then 1 up, which in this case, it will be a positive vector. One thing that I have to say about these vectors is that it don't matter in the um, where in the um, graph is. If it has this value, this specific value, well, let's say that, okay, so let's say that this line or this vector, whatever, was over here, it will still have the same value because its value will not change. So now saying that, we see that we have the value of W. So what we will do in this case, we will go about B1, B2, and we will say 2.5 B1, and then we will say minus U to get the W value. Okay, so let's get into some examples. So based on that knowledge that we already have, or that I already explained to you guys about this graph, we're gonna try and find from question number 7, vectors A, B, and C, and D. So let's get into it. So for vector A, um, as always, we're gonna start at the origin, and then we're gonna see that we have the value of negative 2b, and then it goes up. So the value of this will be negative 2b plus u, because we don't actually know its value, so that will be its. Okay, so we don't actually have like numerical numbers or like numbers to tell us, okay, so this is 1, this is 2, this is 3, this is whatever. No, we have to go based on whatever is it that they give us. We have u over here and we have negative 2, so we will say it's negative 2b plus u. We will do the exact same thing for b. We will say negative 2b, if you want to write correctly, of course, and this will be plus 2u because it is a scale twice. That will be 2u. Now, this is for question number 7, by the way. Then we will have question C, or part C, or sorry, vector C. Um, we see that we move from the original location. So I will say that this is going to be like at least 3.5, negative 3.5. So negative 3.5b. and then plus still the same value to u. And now for d, um, so the negative 2b has moved twice its size. So we will say that is negative 4, yeah, negative 4, let me erase this, negative 4b plus 3u, because it's not in the same location and the value of u has been moving all around over here. So we have to, keep it consistent and stuff. So this is what we will get for 7. Now for 8, we will do the exact, I don't know why I put 7. We will do the exact same thing. But in this case, we will have our B side be positive and our U side be negative for some reason. So let's try and find W first. So with W, we have 2B over here, and we have our um, negative U value over here. So we will say 2B minus U. For X, oh, so this will be W. For X, we will have 2B, 2B minus 2U. For Y, we will have, which is over here, we will have 3.5b minus 2u. And then for z, we will have 4b minus 3u, of course. So I have previously gotten these values before, so that's why I'm able to just write it down like that. But yeah, so this is how you find these values from the graph. I hope you guys like it. Thank you very much. Have a good day.